In this video, we'll talk about how to graph rational functions and also how to find asymptotes for them. So let's talk first about how to find asymptotes for rational functions. Now, an asymptote is a line that a function approaches but never crosses. So if we think about it, there are technically two cases. There's horizontal and there's vertical. And if we think about a rational function, so we have a polynomial expression which we'll represent with a of x divided by another polynomial expression which we'll represent with b of x. So vertical asymptotes are the simpler case. Basically, they happen when we are dividing by 0. Since we can't do that in mathematics, we have no way to define it. It just so happens that's where we find our issues. So to find them, we set whatever our denominator is, which we're calling b of x, equal to 0, and then we solve. Once we do that, that'll tell us where our vertical asymptotes are at, and then we can draw them on our graph and draw around them. Now, horizontal is a little bit different. There's a couple schools of thought. The first school of thought is to just look at the end behavior. Ask yourself, what happens as x, or whatever independent variable we're talking about, gets really big? What happens to y? And whatever this number is, if it's a number, or if it's infinity, whatever it may be, that'll be our horizontal asymptote. Another school of thought is to compare the degrees. If the degree of a of x is greater than b of x, there's no horizontal asymptote. And again, that kind of stems to the end behavior. If you have an x cubed term divided by an x squared term, well, eventually the x cubed term is going to win it over. If we have a of x less than b of x, then our asymptote will be 0. So a horizontal asymptote at y equals 0. And then the last case that we can think about is if the degree of a of x equals the degree of b of x. Then we look at the ratio between the leading terms. So if we have 2x cubed over 3x cubed, it will approach 2/3, for example. And that would be our asymptote. Now, me personally, I like the end behavior because then I don't have to remember 3 rules. I just learn the one and I look at the whole function. Ask myself, what happens as x gets really, really big? Where does it go? And that answers my question. That'll tell me where my horizontal asymptote is. So let's put this to practice. Let's say we wanted to sketch a graph of y equals 1 over x minus 4. Well, the first thing I'm going to do is I'm going to try and figure out where my asymptotes are. So the first thing is to try and figure out vertical asymptotes. Those are fairly simple. I do that by setting my denominator, which in this case is x minus 4, equal to 0. Once I've done that, I can say x equals 4. That's where I have a vertical asymptote. So if I go over to my graph, at positive 4 on the x-axis, I have a vertical asymptote. My function cannot cross that dotted line. Likewise, if I look at the horizontal asymptote, which in this case we're thinking end behavior. So as x gets really, really big in value, what happens to this expression? Well, if I take 1 divided by 1,000,000 minus 4, it's going to be really, really, really small, very close to 0. So I'm thinking as x approaches infinity, y approaches 0, which tells me I have a horizontal asymptote at y equals 0. So the axis line is my horizontal asymptote. Can't cross that line. So the question then remains, okay, what sides of the line am I on? Well, one thing we can do is kind of make a little bit of a T-chart. And really, we just need to know what happens to the left of 4 and what happens to the right of 4. So if we pick something greater than 4, let's say 5. So if x is 5, that means we're going to take 1 divided by 5 minus 4, which is 1, which means we're going to be above the green line. So I think the right half of our curve is going to look like this. It can't cross those lines, and it has to be above the green line because the point 5, 1. So if we look at 5, we're at a height of 1, which means that all the rest of the points should be above that line as well. Now likewise, if we plug in a value less than 4, let's say 3, then we can go through, we can say 1 divided by 3 minus 4, subtract the 3 and the 4, we get negative 1, so negative 1. So that would lead me to believe that if we're at 3 and we're at negative 1 right here, this point is on our graph, that means all the rest of them on this side have to be below it as well. And it can't cross the dotted line, so it must look something like this. This is just one example, and we're going to go through another one here in a minute, but the idea is find your asymptotes, and then graphing these things becomes a lot easier. And again, I say graph, but really it's a rough sketch. Nothing too terribly exact about what we're doing here, but it's a quick mental picture of what this thing should look like. So let's do a slightly more complicated example. Let's go through. Again, we're going to figure out our vertical asymptotes and our horizontal asymptotes. So if we're looking at this, we have x squared equal to, or minus 16 is equal to 0. That's where we'll have our asymptotes. Again, we're setting our denominator equal to 0 because we can't be dividing by 0. This tells me that x squared has to equal 16, which tells me x has to be plus or minus 4. Very important we consider the negative case here. So if we go to our graph, we have 2 vertical asymptotes in this case. We got one at positive 4, and we have one at negative 4. Can't cross those lines. So we're going to have 3 pieces to this function. And likewise, very similar to the last one, as I increase x, well, y is going to approach 0. It's never going to get there, but it's going to get closer and closer and closer. Okay, so I know that the axis line, again, is where I have my horizontal asymptote. Now I just have to figure out what happens to the right of 4, what happens to the left of negative 4, and what happens in the middle. So, let's go ahead, make a rough t-chart. Okay, I'm going to pick a value greater than 4. So if I do 5, I'll have 1 divided by 25 minus 16, which would be 1/9. So that tells me I'm above the line. The horizontal one, anyway. So my right half of the, or right chunk, is going to look like this green curve here. Similarly, if we look at the very, very far left, something less than negative 4, let's try negative 5. We'll take negative 5 squared, we'll also get 25, minus 16 is also 1/9. So very similarly, we're above our horizontal asymptote, and we're plotting just like so. And now we're going to ask ourselves what happens in the middle. What happens if x is, I don't know, 0? So if x is 0, y then has to be negative 1/16, which means that we would be most likely all below the line. So our curve is going to look something like this. So again, rough sketch, nothing too terribly accurate about this graph, but it does give us a very good idea of what this thing should look like should we plug it into graphing software. And that is the main takeaway from this lesson. A lot of times when we're graphing these things, we're not so much looking to get an exact picture of what this thing looks like. We're trying to get an idea of, okay, if I plug this thing into software, quick mental picture, does it look right? Does it match what I'm thinking?